Good morning. I am Dr.S.MUTHUKUMARAN, Assistant Professor, PG and Research Department of Computer Science, St. Joseph's College of Arts and Science, Autonomous, Cuddalore 1. In this presentation, we are going to discuss about Big Data Analytics, Big Data versus Data Warehousing, activities performed on Big Data, classification of analytics, challenges of Big Data Analytics. What is Big Data? Big data is a collection of data that is huge in volume, yet growing exponentially with time. It is a data with so large size and complexity that none of traditional data management tools and stored it or process it efficiently. Big data is also a data but with huge size. Big data is about data volume and a large data set measured in terms of terabytes. This phenomenon is called big data. Big data analytics. Big data analytics is the process of examining large amounts of data. There exist large amounts of heterogeneous digital data. Big data is about data volume and larger data sets measured in terms of terabytes. Big data analytics is a process used to extract meaningful insights such as hidden patterns, unknown correlations, market trends, and customer preferences. Big data analytics provides various advantages. It can be used for better decision making, preventing fraud activities, among other things. Big data versus data warehousing. Big data analytics is the process of examining large data set containing a variety of data types to discover some knowledge in databases, to identify interesting patterns, to establish relation to solve problems, market trends, customer preferences, and other useful information. Combines implement big data analytics because they want to make more business solutions. Big data versus data warehousing. Data warehousing is relational database that is designed for query and analysis rather than transaction processing. It includes historical data derived from transaction data from single and multiple resources. A data warehousing provides integrated enterprise-wide historical data and focuses on providing support for decision makers for data modeling and analysis. A data warehousing is a group of data specific to the entire organization, not only to a particular group of users. It is not used for daily operations and transaction processing but used for making decisions. A data warehousing can be viewed as a data system with the following attributes. It is a database designed for investigation tasks using data from various applications. It supports a relatively small number of clients with relatively long interactions. It includes current and historical data to provide a historical perspective of information. Its usage is read intensive. It contains a few large tables. Data warehouse is a subject-oriented, integrated, and time-variant storing of information in support of management decision makings. New techniques must be introduced in data cleaning, indexing, and partitioning. Provides improved performance for complex analytic queries. Relieves processing burden on transaction-oriented databases. Allows for a continuous planning process. Limitations of data warehousing. It is query intensive. Hidden problems with various resources. Scalability can be a problem. Data homogenization. High demand of resources, high maintenance, complexity of integration, increased end user demands. So for this limitation we have compared big data analytics versus data warehousing. Whereas big data is the data which is in enormous form of which technologies can be applied. In data warehousing is the collection of historical data from different operations is an enterprise. Big data is a technology to store and manage a large amount of data. Data warehousing in architecture used to organize the data. It takes structured, non-structured and semi-structured data as an input. but it only takes structured data as a input. Big data does processing by using distributed file system. Data warehousing does not use distributed file system for processing. Big data does not follow any SQL queries to fetch data from database. In data warehousing, we use SQL queries to fetch data from relational database. Apache Hadoop can be used to handle enormous amount of data. Data warehousing cannot use to handle enormous amount of data. When data is added, the changes in data are stored in the form of file which is represented by a table. Whereas when new data is added in data warehousing, the changes in data do not directly impact the data warehousing. Big data does not require efficient management techniques as compared to data warehousing. Data warehouse requires more efficient management techniques as the data is collected from different departments of enterprise. Activities performed on data, big data. There are three criteria based on activities performed on big data. First one, store. Second one, process. Third one, access. Store. Big data need to be collected in a seamless repository, and it is not necessary to store in a single physical database. Process. The process becomes more tedious than traditional one in terms of cleaning, enriching, calculating, transforming and running algorithms. Access. There is no business sense of it, and when the data cannot be searched, retrieved easily and can be virtually showcased along the business lines. Classifications of analytics. Analytics is the discovery and the combination of meaningful patterns in data, especially valuable in areas rich with recorded information. Analytics relies on these simultaneous applications of statistics, computer programming and operational research to qualify performance. Analytics can be classified into four criteria. First one, predictive, descriptive, prescriptive and dynetic analytics. These are the classification diagram for four types of classification. Descriptive, what have we done in the past? Dynetic, why have we seen past results? Predictive, what we are going and when? Prescriptive, how should we take action? Predictive analysis. Predictive analysis turn the data into valuable, actionable information. Predictive analysis uses data to determine the probable outcome of an event or a likelihood of a situation occurring. Predictive analysis holds a variety of statistical techniques from modeling, machine learning, data mining and game theory that analyze current and historical facts of making predictions about a future environment. Techniques that are used for predictive: linear regression, time series analysis and forecasting, data mining. Descriptive analytics. Descriptive analytics looks at a data and analyzes past events for insight as to how to approach future events. It looks at the past performance and understand the performance by meaning historical data to understand the cause of success or failure in the past. Almost all management reporting such as sales, marketing, operation and finance uses this type of analysis. The descriptive model quantifies relationships in data in a way that is often used to classify customer or prospects into groups. Unlike a predictive model that focuses on predicting the behavior of a single customer, descriptive analytics identify many different relationships between customer and a product. For example, data queries, reports, descriptive statistics and a data dashboard. Perspective analysis. Perspective analysis automatically synthesizes big data, mathematical sciences, business rules and machine learning to make a prediction and then suggested a decision option to take advantage of the prediction. Prescriptive analytics goes beyond predicting future outcomes by also suggesting action benefits from the predictions and showing the decision maker that implements of each decision option. Prescriptive analysis not only anticipates what will happen and when to happen, but also why it will happen. Further, prescriptive analytics can suggest decision options on how to take advantages of a future opportunity or migrate a future risk and illustrate the implication of each decision option. Diagnostic analytics. In this analysis, we generally use historical data over other data to answer any questions or for the solution of any problem. We try to find any dependencies and patterns in historical data of a particular problem. Common techniques used in diagnostic analysis are data discovery, data mining, and correlation. Then we have to see challenges of big data. There are 7 challenges we have to face in the big data analytics. Need for synchronization across data resources. Second one, acute storage of professionals who understand the big data analysis. Getting meaningful insights through the use of big data analytics. Fourth one, getting voluminous data into the big data platforms. Uncertainty of big data landscape. Data storage and quality. Security and privacy of data. In the first challenges, need for synchronization across data sources. As data sets are become bigger and more diverse, there is a big challenge to incorporate them into an analytical problem. If this is overlooked, it will create gaps and lead to wrong messages and insights. Second one, active storage of professionals who understanding a big data analysis. The analysis of data is important to make the voluminous amount of data is being produced in every minute useful. With the exponential rise of data, a huge demand for big data scientists and big data analytics has been created in the market. It is important for business organization to hire a data scientist having skills that are varied as a job of a data scientist in multidisciplinary. Third one, getting meaningful insights through the use of big data analytics. It is an imperative for business organization to gain important insights from big data analytics, and also it is important that only the relevant department has access to this information. A big challenge faced by the companies in the big data analytics is mending this wide gap in the effective manner. Fourth one, getting voluminous data into the big data platform. The amount and variety of data available these days can overwhelm any data engineer, and that is why it is considered vital to make data accessibility easy and convenient for owners and managers. Fifth one, uncertainty of data management landscape. With the rise of big data, new technologies and companies are being developed by every day. However, big challenges faced by the companies in the big data analytics is to find out which technology will be best suited to them without the introduction of new problems and potential benefits. Data storage and quality. Business organization and growing at a rapid pace with the data produced. The storage of this massive amount of data is becoming a real challenge for everyone. The popular data storage options like data lakes, warehouses are commonly used to gather problem arises, diverse resources, it encounters errors. Missing data, inconsistent data, logical conflicts and duplicates data all result in data quality changes. Security and privacy of data. Once business enterprises discover how to use big data, it brings them a wide range of possibilities and opportunities. However, it also includes the potential risk associated with big data when it comes to the privacy and the security of the data. The big data tools used for analysis and storage utilizes the data resources. This eventually leads to high risk of exposures of the data, making it vulnerable. Thus, the rise of voluminous amount of data increases privacy and security concerns. Thank you.